Here is an example about applying what we just learned about fatigue. So 821 shows a connection using a cap screw. The joint is subject to fluctuating forces. That's where fatigue is, whose maximum value is 5 kip per screw. So I already have the external load per screw, P. The required data are cap screw, which is 5/8 of an inch, 11 thread per inch coarse, and it has a grade SAE5. Hardened steel washer of a thickness, so we're using a washer here at the top, which is going to affect my grip length. And of course, there is no nut, so my grip length is calculated based on D and T2. So the washer has a thickness of 1/6 of an inch. The steel cover plate has a thickness 5/8 of an inch. Modulus of elasticity for steel is 30 MPSI. The cast iron base is also 5/8 of an inch. And the cast iron modulus of elasticity is 16 mega PSI. We want to find KB, KM, and C. So another opportunity here to practice how to calculate the bolt stiffness and the member stiffness, as well as the coefficient of stiffness C, using assumptions given in caption of figure 821. So we're looking here at the grip lengths, and I'm looking at a frustum, and this is D1. And you see here, D1 is calculated where the two frusta lines meet. And this is dependent on the grip length. So it would be half the grip length is where I calculate my D1. So you look here at the grip length depends on whether T2 is less than D. So T2 in this case is 5/8 of an inch compared to the diameter of the bolt is also 5/8 inch. So either equation is going to give me the same grip length. So my grip length is simply going to be H plus 1/2 of 5/8. So I can calculate D1, this diameter, using DW plus L10 alpha. Now for DW, I'm going to use 1.5 times the nominal diameter. And L10 alpha is 0.577 L. So this is for D1. Now D2 is going to be the same as 1.5 D, like we used here at the top. So that's going to be D2. L is the effective grip length, and the solutions are for alpha 30 degree and a DW of 1.5 D. I think you'll be able to follow easily through that. This is here to calculate C based on KB and KM. So we're using the equations here to find the stiffness KB. We find KB to be 6.78, and KM was found by looking at a K1, a K2, and a K3, and then we found KM here to be 17.4 megapound force per inch. So this is how we find the stiffness coefficients. So please make sure you go over this. This is a nice example where we're using K1, K2, and K3. And remember that the reason we're using a K1, a K2, and K3 because we have a variation in the material. So you look here at the first frusta, we have the same material. Then for the second frusta, it goes between the steel cover plate as well as the cast iron base. So that's why I split it into two portions. The first portion, and this was the reason we needed to find a D1, and I used that D1 and to find this K2, and then I had a K3 using this uppercase D2. So we had a D1, I'm sorry, we had a K1, a K2, and a K3. We are going to use this C. Oops. So we found here C, and this is part A of the question. And then for part B, we want to find all factors of safety and explain what they mean.